Hello, everyone. Uh, I'm Angelos Georgios, and I'm here to present the Data.gov CSW implementation, which is based on pycsw, and it is using also CKAN integration. So in the next minutes, I'm going to show you how we implemented this project during the last 6 months. Yeah, okay. I probably need to. Okay. So the presentation outline today is I'm going to give a short introduction about CKAN and pycsw, and then I'm going to talk about what are the components of the Data.gov portal, what are the features, which features we implemented during this project, how the configuration was done, and then I'm going to show you some demonstration of how to access the data, how to search the catalog, and what is coming in the next months. So basically, Data.gov is the home of the US government open data. This is the second iteration actually of the project. You're able to find their federal, state, and local data and the resources in order to conduct research and build applications and do visualizations or whatever you want with the data, since it's about open data. The Data.gov project is right now is run by the General Service Administration, but it's now completely open source. So you can find the source code on GitHub, and you can make modifications to it. So the new portal, version 2, is based on CKAN, which is an abbreviation for Comprehensive Knowledge Archive Network. It is an open source web platform for publishing and sharing open data. And it has really impressive history of deployments so far. These are just a few of the well-known deployments, which are the EU Open Data Portal, the Data.gov in the UK, and in Australia, and in other places. And there's also an extension of CKAN, which is actually enabling CKAN to have geospatial capabilities. So it is based on PostGIS actually, and it has integrated open layers. Actually, now it has also leaflet support, and it can access OGC services through OWS lib, and it has now support for CSW through pycsw, and lately there has been a GeoJSON support. So pycsw is an OGC CSW server implemented in Python. It's an open source project, and we are using the MIT license. Currently, pycsw is fully certified by OGC, and we are now reference implementation of CSW, and also under OSGeo incubation. So this is an overview of the history of the project. Initially, there were discussions about integrating CKAN with pycsw, basically because both projects are Python-based. And since pycsw can be used as a library, there were initial discussions in 2011 about doing such an integration. Then in 2012, actually, OKFN and Data.gov team partnered up to build this version of Data.gov. So then OKFN implemented the first prototype during the first months of 2013. And then GSA took over the project and the extensions that were developed in order to continue and bring the project to deployment and to production state. So at some point, CKAN had an internal implementation of CSW, which was used in the UK, but there were some issues with it. So they finally made the choice to drop the internal plugin and use pycsw as the official CSW library. Then, when the pycsw was actively involved in this implementation, we started working on new features that would cover the needs of Data.gov, things like full text search, and repository filtering and connection pooling and stuff like that. I will talk about that later. And then we released in early 2014, we released the pycsw 1.8, which was based upon the work we did for Data.gov. Now, currently, we are actually Saturday, we're going to release 1.10 for pycsw during the code sprint here. And this is the version that is going to be updated on Data.gov also. It brings new features like open search. I'll talk about that later in more detail. So the goals of the project, in our perspective, were to be able to deploy pycsw as a WSGI application directly into that URL you see over there, to be able to synchronize the metadata between CKAN and pycsw, because both projects have different database schemas. Then to provide collection level support, because CKAN now for Data.gov uses collection, uses a special extension to CKAN and uses data collections. Then we had the big issue of making this run very fast. And we had to optimize for performance during this project. And we did some documentation and worked on the deployment configuration stuff. So this is a short diagram of how this project is being implemented. You can see that the core software is CKAN, which is actually working on top of Postgres and PostGIS, actually, in order to be able to do spatial queries. But in order to perform fast queries, CKAN uses Solr. But the latest versions of CKAN actually can do spatial queries through Solr, but still PostGIS is used because it has more features. Also, as you can see here, there are many extensions in CKAN on the left. The Data.gov extension was implemented directly for this project. And also there are other plugins like the harvesters and the spatial extension. I'll talk about later about how we deploy using Ansible and RPMs and stuff like that. So pycsw was used as a search engine next to Solr in order to provide the CSW interface. So CKAN is very successful because it's targeting governments and companies and organizations, and they're trying not to, they are looking at all kinds of open data, not only geospatial. So today CKAN is not about only geospatial software. So the good thing is that it provides loosely coupled services which can be turned on and off according to needs. And this was a very successful project, and it has capabilities like publishing and finding data sets, storing data, creating networks of federated nodes, of harvesting between different sources of data and metadata, doing editing and management of metadata, and also it has a very strong API which can be used directly to give access to the data. So I have some screenshots of how the original CKAN looks like, where you can actually do searches through the user interface. CKAN is a Pylons project, so it is a Python-based project, and search and discovery is done through this user interface, where you just type keywords and then you get results. And based on the results, you can redefine your searches, or you can use keywords or topic categories which are provided by the user interface. Also, you can you can actually look into the metadata that are provided with the data, and it is very capable of using lots of many kinds of metadata. It can harvest from many sources, and this is a very powerful feature of CKAN. Also, there's there's a feature of using of visualizing geospatial data sources directly on a map. And also, it can do the same not only for maps, but also for grid data, and it can create graphs. So the spatial extension specifically uses adds actually one spatial column to the Postgres schema of CKAN, and it uses that to perform queries and display the results to the front end. For this project, for Data.gov, we have been using, we tried to use only ISO XML metadata. So actually, when we harvested from various other catalogs, we were doing transformations to ISO in order to have a unified XML representation of all the metadata. And this is the UI as it is implemented today. So there are some extra capabilities that are added to the CKAN core. Like you see the CKAN extension, the spatial extension adds the map to the left where you can actually create bounding box searches. And you can refine the search with keywords. And also it can do, a nice feature is it can do relevant searches in terms of the bounding box. So it will give you first the results that are actually fitting better to the bounding box that you give. And this is a nice thing to see more data that you are expecting to get. So this is also how it is performing this filtering that I told you about. So then when you actually find the data set that you are looking for, it provides all the resources and the metadata in order to be able to view and download the data. So you can send from this page, which is the resource page, you can directly go to a map and see a WMS, for example, if there is such a resource. Or you can click on the original XML file and you can directly look at it. But there are also HTML viewers for that. So you have different choices in terms of how you see your data and metadata. A big topic in this project was to be able to visualize many different kinds of resources. So there are things supported like WMS, WFS. You can actually download shape files, or you can download even spreadsheets directly from the user interface. Also, as part of the CKAN, there is a dataset preview extension where you can actually see the data, the spatial data within a viewer, if that is possible from the original resource. And this is how you get to see the XML, the original XML file, if you click on the URL. So this is the CSW interface, which was implemented directly into the CKAN deployment. So here we see something more than 400,000 records within the CSW endpoint. So what are the features that we implemented? Basically, we needed to replicate the way that Data.gov does the collection. So Data.gov has collections. Instead of showing to the end user 400,000 records, it uses collections as an intermediate layer. So you get to search something like 80 to 90,000 records, which are actually collections of metadata. So we needed to be able to do that, and this is why we implemented a filtering process where you have your catalog and you have 400,000 records, and you can actually filter those with an SQL query, depending on if this is a collection data set or not. And this was needed because we needed to have persistence, to have like similar behavior of the CSW with the CKAN search. Then we did some work on the database pooling for WSGI in order to be able to deploy within the environment of Data.gov. And actually, the most important feature in this process was the Postgres full text search. This was the feature that made actually the CSW endpoint really, really fast. So there's no problem searching those 400,000 records or even more, because Postgres has this nice feature that can actually index all the data. Then we did some work on the link type detection. The big problem is that on Data.gov you get resources from all those organizations around the US where you have data like shape files within zip archives when you don't know what it is inside. So this was a pretty tough problem to solve, and actually we didn't solve it, but we kind of worked towards managing it. So like another problem would be when you have a WMS which doesn't actually has the word WMS in the URL. What do you do then? You might get OWS. What is that? Is it WMS? Is it WFS? What is that? So there were problems like that, and the original metadata provided by many organizations didn't have the link type in it, so we didn't know what kind of data it was. And we made some heuristics in order to be able to solve easy cases, but some other cases were not solved. And now we need to ask for the organizations to provide new metadata, which is something that nobody wants to do, actually. So, and also the last addition to our features is that we are the first to implement the OGC OpenSearch geo-in-time extensions, because it happened like 2 months before we release, and it was something that people wanted. So this is the extension that lets you do OpenSearch queries and providing a bounding box and not only keywords. So this was implemented in pycsw, and actually this is going to be released on Saturday. But it is already in the Data.gov CSW deployment. Apart from what we did for this project, I'm just showing you some features that pycsw is already doing, like harvesting WMS and WCS and all those standards. We support ISO, we support FGDC. We implemented the Inspire, we have been using the Inspire documentation to implement the service. And we also support many databases. We can work off an SQLite or Postgres or whatever is possible to be done through SQL Alchemy, actually. More features. We try to keep it simple. The configuration of pycsw can be done in 4 minutes. It's actually very, very simple to do that. And we have a very extensible plugin architecture where you can, if you have a database, if you have your own schema of metadata, you can actually create a plugin so that pycsw can understand your schema and provide responses to queries according to your database. This requires, though, a bit of coding. It is already integrated with portals and other Python projects like GeoNode and Open Data Catalog. And we can do also real-time XML schema validation and stuff like that. And these are the standards that we are currently supporting. So I won't go through that list. It's a long list. So how did we actually configure and deploy it? It was a long process. It was not something that was done actually in a few days. And that's why also we didn't have any access to the physical machines. We had to provide every step of the deployment on an email, actually, or in some kind of, we didn't have access. So we had to automate everything from every single thing that would be done through a terminal. We need to automate everything. So actually, there was already work done there, and the Data.gov people were using Ansible for that. So we just picked that up, and we provided Ansible scripts to do the deployment. The tricky part is that Ansible is not used directly into the servers. Ansible is used to create the RPM packages that are then deployed to the servers of the GSA. So it was a two-level deployment scheme. There we first create the RPM packages, and then those RPM packages are sent to the production servers. This way, every 1 month or so, yes, 1 month I think, the GSA is actually updating the portal with new patches and new features. So this is an easy way for the administrators to upgrade their system. 3 types of clusters there. We have database cluster, front end, which is the CKAN and pycsw, and also we have a cluster for harvesters, because harvesters are actually doing the hard work. They're harvesting from every source of metadata that is available around the US. So it needed a specific set of hardware. And we are using CentOS as the operating system to do that. Now, okay, the catalog is here. How do we use it? we have CKAN. We can do it through the UI, but why do we have CSW? How can we use CSW? So part of the project was to document this process, and this is why we created a set of documents so that the users can actually do and understand first, and then do some simple CSW requests. So here I provide, there are some links on the documentation. Actually, this presentation is available on the internet. I will give you the URL on the last slide. But also there are many other tools that somebody can use to access the data. One of them is QGIS, actually, where there is the meta search plugin, which is now a core QGIS plugin. So whenever you install QGIS for 2.4 or a later version, when that comes, you are able to use the meta search plugin to actually search the metadata from Data.gov or any other CSW server out there. And also, you can use any other CSW server client that you can have. So I already told you about how Data.gov organizes the data in collections. So these are the 2 endpoints that we provided for the CSW implementation. So we have the first order of the collection level filtering. This is the URL where you can you can search the collections. And then when you search the collections, you can actually specify the ID of the collection in order to go to the second endpoint and search within the collection. So there are 2 actually interfaces instead of 1, just to be able to reproduce the workflow that you can do on CKAN UI. So since Data.gov uses CKAN and pycsw, others became very interested in that. So suddenly we hear from other organizations that want to reproduce this installation. I have met many people here. I'm very happy to be here and being part of this process. And a few weeks ago, NOAA deployed the CSW extension there. And you see there are more are coming. So we have also a live deployment map where you can find who is doing that. what did we learn from this process? The first thing that we learned is that you have to optimize your database. This is something that cannot be done without database tuning. And actually, databases need to be really fine-tuned in order to be able to do this kind of heavy lifting of metadata and searches and everything. Also, it's very important to be able to have you have to create packages, and you have to be very careful of the dependencies and how you deploy this software into your production machines. So it all came down to using the full text search of Postgres in order to be able to be really fast. And this is also part of the upgrade of Data.gov to the latest Postgres 9.3, which actually was very fast. Another thing that we learned was that identifiers are very important. And what I mean by that, the original metadata files had, oops, what happened here? I don't know why, but okay, I'll continue. So the original XML records from all the sources that we harvest have some identifiers in order to be able to know to index the data. So CKAN does something a bit differently. When it harvests, it creates new identifiers for the records in order to be able to know internally how to manage internally the metadata, and that was very important because we had to find ways to synchronize or to couple the identifiers, the original ones and the new ones. So this was a bit of trouble, but it was at the end it was made possible. Also, some problems where the original metadata were not the best we could ever find. I mean, there were issues there, and sometimes we had to actually ask for updates. And this is a work in progress, and some issues are already always there, but they are going to be fixed eventually. So in the future, what we want to do is to do a deeper integration in terms of not synchronizing between two databases, but using only one database. And this is also a work in progress. The next big thing is going to be CSW3, which is actually not yet released by OGC, but we are already working on that. And I think at some point in the next few months it will be released. So we have some time here to show you a couple of things like the actual UI and how you can perform searches directly on CKAN. So this is the Data.gov portal. Don't have enough time. Okay, I can. 2 minutes. Okay, then I'll just. Well, actually, if we have 2 minutes, I can show it another time. So I will skip that. So I want to thank the USGS for supporting this project, and James Bauer, who we worked together for many months now, the FGDC and the GSA and Data.gov development team, and the integrators CONSO and REI. And a big thanks goes to the pycsw development team, Tom Karlidis and Adam Hinz. Unfortunately, the project manager, who was Doug Nebert, passed away during a few months ago. So I want to dedicate this presentation to him. He was a really inspiring person who made this possible here. And he was very passionate about CSW3, so he never got to see it, but anyway, that's life. So this is for Doug. Thank you very much.